Hello, welcome everyone. If you were wondering why this sound sucked so bad, then stay tuned also for some other information, because I will tell you what I recently added to this project, why it sounds like crap and why it is still beneficial in the future. Okay, so first things first, I added my oversampling stuff to this plugin and now it can be turned on and off, currently just between no oversampling and 4 times oversampling. And yeah, when oversampling is enabled and also playback on the audio happens, then the CPU waste looks like this. My plugin has a terrible performance now. So before going into the details why that happens, I will compile the same project in release mode. I can also enable the other plugins here, and let's check out the performance. So, as you've seen, this performance also sucked really bad, but it was way lower than the debug mode version, which is kind of surprising in my opinion. And I will show you what I think the reason for that is. First of all, I have to make a little announcement. I changed something about the oversampling class before integrating it into this project. In my last implementation of the oversampling class, I had the concept of an oversampling processor listener, and all of the other classes that kind of relate to things like the sample rate or the block size, they had to be oversampling processor listeners and then added to a vector of pointers that point to the listeners inside of the oversampling processor, so that when the sample rate or something changed due to another oversampling stage being chosen, it could go through all the prepare to plays of each listeners and well call them. And then I realized that that was kind of pointless, because there is a general prepare to play already in the plugin processor, and all I need to do is calling that. So what I changed is I give the oversampling processor a pointer to the audio processor, which I save here. And now in the upsample method, when an update is true, which means that something about which oversampling stage is being used has changed, then I'm just calling the prepare to play method of the general audio processor. And now you might be wondering, well, but usually prepare to play is supposed to be only called by the host and not by the plugin itself. Then I say, yeah, that might be true, but you know, the upsample method is the first method that happens in ProcessBlock, or more like there cannot be some other DSP processor running in parallel while the upsample method runs and does its thing. So if I'm calling prepare to play here and there are a lot of reallocations of buffers and stuff, then that's totally safe if I just return from ProcessBlock after doing this, which is the case because I return null pointer. And yeah, that's much more smooth now, because now I can write all my DSP classes without inheriting from some sort of listener. And also, I could get rid of the latency handler that I introduced in my last video. I thought it was a very smart idea, but now I could actually get rid of it, because in the prepare to play method, I'm just getting the latency of this oversampling thing, and whenever some other processor also produces latency, then I just add that latency And then at some point, some processors might want to know how much latency something creates. Well, I just give it the latency value, and so on and so on. So it's all handled by the prepare to play method that we already have in Love. So there is no need for a latency handler, which makes this much smoother to implement. Now, after all these things that are honestly very elegantly implemented, and I really have to say that I did a really good job about that so far, you might ask yourself, then why does it still waste so much CPU? And it seems like it sucks really bad. And the reason for that is probably that I have a lot of things in this project. And one thing that I did not think of when I made my oversampling class was that there might be a lot of DSP related things that don't really need oversampling. In my oversampling example project, I had some gain parameter that I applied to the buffer after downsampling it. And that was maybe a little bit of a thing that does not need oversampling. But this is a real VST project that has a lot of stuff where you have to dig a little bit deeper. Let's check out the ProcessBlock method to see what I mean. For example, here in the beginning, I have the mid-side processor, which sometimes converts the signal into mid-side mode and later decodes it back if needed. So this definitely does not need oversampling, and that's why it comes before this kind of stuff. So I already separate some stuff from the oversampling stage, but it's not enough, as you will see very soon. So here the oversampling upsamples the buffer if needed to a new buffer, and then I'm clearing the VIP delay, which is basically a little audio buffer that captures all the modulation data from the different modulators. So if I'm running this project in a standalone version now, you see that there are two modulators going on all the time. I mean, that's kind of the whole point of this plugin at the moment. And both of these modulators write into the VIP delay. So of course, at the start of each process block, I have to clear this buffer. And at the moment, I clear it with the number of samples from the upsampled buffer. So that's not too much of a problem at this point. This is just two channels that are being cleared. That's almost nothing. So then the ProcessBlock modsys function processes the whole modulation system that I wrote. Now, what does that mean in an oversampled way? If you have watched some of my modulation system videos where I talk about this modulation system that I'm working on, and it's still not finished, as you can see, very soon, because one of the weaknesses of my modulation system is that every parameter has its own buffer. Like you give it the audio processor value tree state and the parameter ID, and then it will get some stuff from that, and it will also make a little block where it can write parameter data into. And I thought that this is a really cool feature because I can just pass the number of samples into ProcessBlock and then apply some smoothing to the parameter. And every parameter can have its own smoothing length in samples. And yeah, I thought that's pretty cool because it means that in the plugin processor's prepare to play method, I can just specify the speed of each parameter that should have a different speed than instantly and be done with it. But the problem is when the block is oversampled, then each of these parameters will just have 2 or 4 times as many samples to smoothen. And I think that's kind of terrible enough already, but it does not stop there. In the modulation matrix ProcessBlock, you can see that after processing all the parameters that are currently active, I also process all the modulators that are currently active. And they also ProcessBlock. Not every modulator has its own audio buffer, but they all share the same audio buffer that is just passed on and always cleared and rewritten too. But it will also use the whole buffer from 0 to num samples times 4. So for each parameter and for each modulator. Now there are also destinations. What does destinations do? Well, it sends the modulation data to all of the destinations that are being set. So at the moment in this plugin, there is one destination from whatever modulator is being used up here, and there is one destination for the one that is down here, and there is the destination of each of these macro thingies. So they are also all destinations, and yeah, they are also all processed in the oh shit, there is a graphics glitch that these things never repaint. Good to know. Anyway, so they are also all destinations, and all these destinations are also upsampled at the moment. And the question I'm asking myself is this really necessary? Because when I implemented oversampling, my initial idea was that just the vibrato should be oversampled. So basically the vibrato is a delay, and the delay is applied on the signal, on the audio signal. And all the other information this delay needs to work as a vibrato is the VIP delay buffer. So the VIP delay buffer should have the same size. It should be upsampled. So what I want to do in the future is I want to decouple the modulation system from this. Actually let it be unoversampled constantly. So kind of having it like over here or something like that, and maybe also outsourcing the VIP delay from this, and then having another VIP delay that is only for the upsampled VIP delay stuff. And every process block, after processing the modulation system, I would upsample this VIP delay to the new VIP delay, and only then I would apply the processing of the vibrato and then the downsampling. Even though I have not tested yet if that is the solution to my problem, I'm pretty sure that this will already change a lot, because as you've seen, it makes a lot of difference if oversampling is enabled or not. I think until the next episode I will have figured out how good it is to just outsource a bunch of stuff from this.